Hi Year 12. Today we're going to be looking at annuities. So an annuity is kind of like a savings account where a person is paying money in over the life of the loan. So far we've looked at amounts of money going into a bank account and then they just sit there and earn interest and no extra money goes in and none comes out. So an annuity will be where we start with a certain amount of money and then money is added in every year or every quarter or month or fortnight, depending on the scenario. So this is going to be slightly more complicated than our normal compound interest calculations because extra money is being added on as we go. So we're mostly going to be looking at superannuation accounts, which is a retirement savings account that a percentage of your salary is paid into by your employer. So it's state or federal law now that everyone has a superannuation account and your employer pays money into that automatically. There are some industries where that doesn't happen and it's actually taken out of your pay, but that's accounted for in your contract. So if you don't really know a whole lot about superannuation, then I would suggest that you have a chat with your parents tonight when they get back from work and talk to them about if they have a retirement savings plan or how much goes into their superannuation each week, because it's something that you will need to deal with once you get a job. All right, we're going to look at an example of calculating final amounts for a superannuation account. So in this example, we have Daphne, who invests $1,000 into a superannuation account at the end of each year. That's important that it's at the end of each year, and she does this for 5 years. The account pays 9% interest per annum. How much will she have at the end of 5 years? So because she's putting in $1,000 every year for 5 years, we're going to need to do 5 separate calculations. So I'm going to show you 2 ways of setting this out. The first way is using a table. So we have 5 years, which means I have 5 rows in my table for 5 separate calculations. She's putting in $1,000 each year, and that's going to be the same for all 5 years. But for the first year, she's actually starting with nothing because she puts her $1,000 in at the end of the year. So her final amount for the first year will be the $0 that she started with, plus the $1,000 that she pays into the account, but she doesn't actually earn any interest on that $1,000 because she's put it in right at the end, which means her final amount is $1,000 for the first year. This then becomes what we start the second year with. So $1,000 now becomes the principal for year number 2. So to calculate the final amount at the end of the second year, she starts with this $1,000, but then she's getting 9% interest on that $1,000 that she started with. So if I use my compound interest formula, it's principal times by 1 plus the interest rate as a decimal. So 9% as a decimal is 0.09. And this is just for 1 year, so it's to the power of 1. Now I'm going to rewrite this. I'm going to take that 1 and get rid of it because to the power of 1 means that we're not actually changing anything. And I'm also going to take 1 plus 0.09. Hang on. And I'm going to combine those and actually add them together, which means I no longer need the brackets. So this is just a neater way of writing that. 1 plus 0.09 is just 1.09, and that's how I'm going to write this from now on. No brackets, no power. Okay, so that $1,000 will earn an extra 9% interest, plus at the very end of that year, she's adding in another $1,000. So at the end of the second year, she has $2,090. So now this is going to follow the same pattern the whole way through. $2,090, our final amount for the end of year 2, becomes what we start with in year 3. That 2,090 earns 9% interest, so I'm going to times it by 1.09, plus she adds in an extra 1,000 and ends the 3rd year with $3,278.10. This amount starts the 4th year, so 3278.1. In my calculations, I'm going to multiply that by 1.09 so that I'm calculating the extra 9% interest, plus another $1,000 added in at the end of the year gives us $4,573.13 at the end of the 4th year. And then the same for the 5th year. We start with 4573.13. That amount earns 9% interest, so I times it by 1.09, plus the extra $1,000 at the end of the year means that we end the 5th year with $5,984.71. So you can see already the calculations are going to take a fair bit longer than if we just had one amount of money sitting in the account earning interest. The other way of setting out this scenario is using the formula. So this formula has a couple of variables in it. The first bit is really just your compound interest formula rewritten. So A becomes our final amount at the end of the year. P is the amount that we ended the previous year with. So you can see in our formula we've got Vn plus 1 and Vn. That means the value, let's say n was 1, this would be the value after the 1st year, this would be the value after the 2nd year. So it's just 1 year later, or one time period later. Then n is always for one time period, which is why it doesn't exist in this new formula. And then D on the end is the contribution. So this is the extra bit of money being added on. So it's pretty much the compound interest formula. No power because the power is 1, and then we're adding in a contribution. So the way I would set this out using the formula would be that V1, so the value at the end of year 1, is what we started with, which was $0, times by, and again this bit in brackets, 1 plus 0.09, I'm going to write as 1.09, plus the $1,000, which will give us $1,000 as a final amount. V2 is going to be V1, which is this $1,000, times by 1.09 plus 1,000. V3 will be whatever we ended year 2 with. So V stands for value at the end of year 2, times by 1.09 plus that extra 1,000. And you can see that this matches pretty much exactly with what we did in the table. The value at the end of the 4th year will be the value at the end of the 3rd year, times by 1.09 plus 1,000. And then V5 equals V4 times by 1.09 plus 1,000. Now, I haven't filled any of these in because I want to show you a shortcut on your calculator. If you type in this line into your calculator, but obviously instead of V1, use the $1,000, then hit equal, it will tell you 2090, which is also what we got in the table. If you then backspace on your calculator, or sorry, just use the left arrow key and go back, change V1, where you had that $1,000, to answer, which is the button next to the equal sign. If you type that in and hit equals, it will use that as your answer, and it will be calculating this line. And it should tell you 3278.1. I'll add a 0 because it's dollars and cents. Then if you hit equals again without even touching anything, because you've got A and S on your calculator screen, that will change to the most recent answer. So then it should straight away tell you 4573.13, and if you just hit equals one more time, 5984.71. So if you're using the formula, you can write out your working and then just type your formula into your calculator once with the answer sign and then just keep hitting equals and it will spit out the 5 answers for you. So that's an example of how to calculate the final amount in a superannuation account.